We are about to begin the session number 6 for the day. Topic we are covering will be fostering new age automobiles and heavy transport, EVs, road tankers and buses.
I'm Pramod Kathuria, looking after purchase department in Victoria Auto from last 25 years. So this is a small presentation which I want to give about something about my company and something about future of stainless steel and what's the status of now stainless steel which we are using. So we are Victoria Auto. We are making stamped components, forged components, casted, machined, tubular parts, raw material, all mainly in stainless steel. So we are doing export of all these components as you are seeing on the screen. We are having warehouses, central warehouses in US and Europe both. 80% of our sale is of export. So we are making components for exhaust products like seat frames also, pedal assemblies, stamping assemblies, metal fabrications. We are into rotors. We are into transmissions and motor components of e-mobility. We are into electronics also, hospitality and elevators also. So what's our technical capabilities? We are into stamping, as I've told you before. We are into stamping. We are into tube and wire bending, machining, forging, aluminum casting, investment casting, assembly parts, proto parts, electronics, motor assembly. So all this you can see the technical capabilities with photographs also. So this is a automobile car in which our components are being used. So if we consider overall automobile stainless steel, where in a car or in a bus, how much stainless steel is used? Like the components which we are making is of exhaust components. So around 90% of stainless steel is used in exhaust. So this is the small like forging components and another sheet metal components and pipe components which is shown in the presentation, which we are using. So this is the pedal assembly, engine mounting brackets, door latches. So this is our consumption of stainless steel yearly. In flat products, 24,000 metric tons. In long products, 15,000 metric tons. In tube, 3,000 metric tons annually we are using. There is a question which is coming in our products like exhaust combustion engines. So what is the future of combustion engines? What to have the 90% of stainless steel is used in automobile in combustion engines. What will be the future of stainless steel in there? Like now we are, as I told you, that 80% of components which we are making or assemblies which we are making, we are doing export to Europe and America. So in last 2 years, we have got the share of business more as compared to before. So it is not that the e-vehicles are much replacing in Europe and America more as compared like what the news which we are getting, because our business is growing there. Because every 1,000 person, there's 1,100 cars are being manufactured. So it will take much time to them to convert all combustion engine to EV as compared to India basically. So and further, what is the replacement of stainless steel which is being done in automobile, that I want to discuss with you. Like in Europe, already Euro 6 is going on. Euro 7 is about to launch, in which there are some changes in e-heaters. E-heaters are being provided in an exhaust system to heat the exhaust before only, in which high nickel products are being used, which prototypes we are making for them. So further, we are also in discussion with our customers, or they are making prototypes for hydrogen engine, in which fuel tanks are being used and exhausts are also being used, in which stainless steel is being used. So, and in India also, like we have seen the NGT norms, in which some vehicles are being disposed of after 10 years of diesel engine and 15 years of petrol engine. So in this, the consumption of stainless steel in India might also go increase. Thank you very much.
I would like to thank everyone for attending this session. So the world is moving towards new designs, new technologies, and if stainless steel gets a chance, then I think it can work wonders. So today I would like to throw some light on some critical applications of stainless steel in electric vehicles and buses. We can start with the electric vehicles. So here we see that the car makers have plethora of challenges. I mean, there are so many challenges. Of course, this list is not exhaustive, and I think Mr. Katuria would know much better than me. It's very complex. And so what could be the criteria for right material selection? So if we see that list here, that also consists of various aspects which are all important. But maybe we can discuss some of them, like the physical property, corrosion resistance, processability, component design, sustainability. And I am not trying to demean the other ones, but maybe from the stainless steel application point of view, I would like to highlight some of them. So coming to the first one, this is related to the crash safety. So in 2017, there was a study done when in fact the electric vehicles were not very significant in number. So it was found that if that vehicle is running for more than 64 km per hour, and if there is a side impact or a collision, then it can result in a very severe accident. And in 57% of the cases, that can happen. And in 26% of the cases, it can lead to fatalities. So this is a very, very high number. Now, if we look at electric vehicles, basically on the underbody floor, it is all battery modules are there. So even if there is the speed at slightly more than 64 kilometers per hour, and if there is a side impact or a collision, you can imagine that there could be a thermal event which would take place, which means that there would be a self-ignition or a spontaneous combustion of the batteries, and it could lead to a very severe accident. So in these cases, probably the victim could be trapped inside in a unconscious state, and you would need some kind of external help to bring the victim out and it save his life. So there was an experiment done where they actually put a sheet on the U-shaped channel, and they kept it for 10 minutes, considering that, within 10 minutes, if there is a collision, then if in an ideal situation, the victim would be brought out of that safely. So aluminum actually deformed at 600 degrees centigrade. So you can see the picture on the right, what has happened to it. But when we talk about the mild steel, in fact, that material performed much better. But at 1000 degrees centigrade, it lost its stiffness. And but when we look at the third one, which is stainless steel, the grade 1.4301, that showed heat resistance up to 1250 degrees centigrade, and it did not even lose the stiffness. So stainless steel can definitely be used as one of the applications related to safety. So this is one of them. The second one is a stainless steel battery housing concept. Actually, this model was prepared with the help of some external partners, and it was based on some feedback from some customer cases. So what the planned design was that each and every part would be built of stainless steel to see that how the component is performing. And if you see here, the most important aspect or a change from the traditional battery housing is that they have put in a battery shell which has a which is deep drawn. So this particular concept was brought in from the cross-industry concept of deep drawn kitchen sink, and this is planned to be developed from a single forming process. So there are no multiple processes involved, so there would be no welds and corrosion resistance would be high. And below there would be something like passive cooling system, a thermal management. So the whole plan was that in the battery shell you have above that you have the cross and longitudinal member and the battery modules and electronics, and it would be the top case would be a flat one, and on the sides you will have the crash frame, which will help in preventing any kind of deformity on the battery. And below that you would have the cooling system, and the whole equipment would be covered by an underbody protection. So this was one of the concept, and they found that because it is of very high strength, the whole weight of the component is coming to about 175 kgs, and this could be one of the concepts with respect to the traditional aluminum battery housing concept. The third one is about the stainless steel fuel tanks for hybrid vehicles. So by 2030, it is projected that the hybrid electric vehicles could go up to 2030 by about 47 million in number. So when we imagine the normal fuel tanks, which are actually in plastic, so how could they resist the in-tank pressure? So the most important aspect is that when you have a hybrid vehicle and when it goes in the electric mode, the engine stops and then the fuel vapors create lot of in-tank pressure. So to resist that, you need a material which has a pressure resistance. So stainless steel is much better as compared to having something like a plastic fuel tank. So of course, the other benefits is about the weight saving. So you can have the wall thickness of as low as 1 millimeter. So this would mean that you have a lower carbon dioxide emission because you're producing much lower volume. And because of the reduction in the volume, you're also increasing the space in the tank, so you can accommodate 3 liters more of fuel inside the tank. And the other benefits like corrosion resistance, and the other one is about the baffling, where you can have a better baffling mechanism to reduce the noise of inside the tank. So that is also one of the advantages with respect to the plastic. So the sound can come down to about 4 to 5 decibels. Now coming to the buses, we have seen that the shift from carbon steel to stainless steel has been very slow. So it's just about 10% as of now. But there is a projection that in the coming years, there would be a lot of requirement of the alternate to fuel vehicles. So the growth of electric buses is going to go more than 75%. So what could be the benefit? So here is just a example of the comparison between carbon steel material. Here you see that is 355 MC and S460 MC. So the name is basically denotes the yield strength of each of the material. And if you compare it with the focused grade, which is FOTA H100, the yield strength and tensile strength is way above that. So what could be the performance criteria? So if you see here, there has been some kind of experiment done, And if you see the picture itself, it shows that how resistant FOTA H100 is with respect to the other materials. Then we also see that because of the high strength of the material, we also have the other advantages where we can reduce the thickness, we can adjust the position, we can reduce the number of tubes in the bus. This is just to give an idea about the chemical composition. So it is a nickel-free material, and it has chromium of about between 12 to 16% and nitrogen of about 0.2 to 0.4%. So this is another pictorial illustration about how it behaves at this, at a drop weight of 433 kgs. So basically one advantage of this particular material is that it re-hardens. It is already work hardened at cold rolling, and when it crashes, it performs better. So it re-hardens during crash. So if you see here in terms of just a simple explanation, not getting too complicated. So if you look at the dark blue line, which is the standard for that material, so the yield strength, which is shown in green color, so that is about 800 megapascal, whereas the tensile strength is close to 1000. And when you see the first impact, which is in gray color, light gray color, then it has the yield strength has increased to almost 1200, whereas tensile has increased close to 1400 megapascal. And then again, for the second impact, it increases even more, which is shown in the light green color. So this is another pictorial illustration about, again, before crash and after crash. So they have shown a graph where you can see that the graph for after crash is much higher in terms of strength. So there was the other aspect is about the bus frames. So they had done a study, basically a simulation of how it could be if we combine both stainless steel and carbon steel material. So there was an experiment done where they did a combination, and they tried to find out that what could be the optimum way of having the best weights with weight saving and with better performance. So this is what they did, was one of the experiments actually on the actual bus project. So here if you see in the first one, in the first case, where the material has been used 100%. So in the first one, it is carbon steel, S480, 460, which has been used 100%, but the mass saved is only about 116 kgs. So weight saving is about 3%, and in H800, when we take it full, then the mass saving is about 1193 kgs. So weight saving is about 33%. But when we try to do some combination here, so that comes to the third line where we have the top main frame of carbon steel, and that is about 91% of the share. And then we have 9% share of the material of H800. So the combination is giving us a saving of 971 kgs, which is about 25%. And when we have the top main frame of H800 along with carbon steel, where the share is about 72% of S460 and 28% of H800, then the saving goes up to 1297. So it is almost about 35%. So the center of gravity also reduces, which helps in the safety, overall safety while turning and making some adjustments. And also the welding volume is reducing to 51.3%. So this is about the material cost. Here what they have done is they have found some factors. So like what could be the cost difference. So in one factor it is 2, means H800 is 2 times costlier than carbon steel. The other one is where it is 2.5 times costlier, and the third one is where it is 3 times costlier. So when it is 2 times costlier, it's about, cost saving is about 18%. When it is 2.5, with top mainframe as 460, it is at 13%, and in factor 3, it is lower at 9%. And of course, when top frame is of H800, where the share is slightly higher of H800, and in that case, 2.5 is 9% lower, and fact 3 is slightly lower. So in the summary, I would say that we have done a nice prototype project just for the bus, and we have tried to find some ways of weight saving through this hybrid concept, and I think the work doesn't stop here. I think we need to analyze more to find out what more could be there, what more concepts we could start, and look at more cost advantages. But in all, I would say that stainless steel still remains the showstopper in many of the critical applications, especially when it comes to human safety. So I think the material as such can do very good contribution to the society. Thank you very much.
What I'm going to do is, in my presentation, I'm going to, move along a similar line. So first, we will touch upon what are the critical factors, what we look at when we select a material for, any vehicle, buses, trucks, or any transportation components. Second is why stainless steel, because there are so many advanced carbon steel, high-strength carbon steel. So what is the USP of stainless steel? And finally, we'll look at, what are the various developments that have happened in India in this particular segment with actual case studies. So, so when we look at, material selection, there are 3 most important things that we need to look into. First and foremost is safety. Like Nagma had already mentioned, 2 most important criteria over here are, one is the crash resistance properties, and second is the fire retardant properties. And thirdly, the material should have a combination of strength, ductility, toughness, and fatigue. Second is savings. From the Indian perspective, and we've been in touch with all the automotive manufacturers. So this is, this becomes a very, very critical segment, because they look at, cost savings in almost every area of their application. So for savings to happen, we need to have a material which has a substantially higher strength than carbon steel. This is going to enable them to, lightweight the vehicles, and therefore when we have lightweighting, as you all know, there will be immense savings in terms of diesels, and we will also show you some actual case studies when lightweighting has, enabled, a lot of diesel savings. And finally, we need to have a material which has a very high corrosion resistance, because the country where we live in, it's a highly corrosion-prone country, and therefore this is of paramount importance. And finally is sustainability. So, in today's context, I think this is one of the major enablers of stainless steel in this particular segment. So with that, I'll just move forward. Corrosion. Corrosion is a major problem across the globe. And if you look at the annual cost of corrosion globally, it almost amounts to $2.5 trillion US, and which is almost equivalent to 3 to 4% of the global GDP. If you look at what's happening in India, so India loses 5 to 7% of its GDP due to corrosion annually. And if you look at the annual loss because of corrosion per se, so it's about 6 lakhs crores of rupees. And if you look at the contribution from the transportation segment, it's almost 2 lakhs crores per annum. And this is not surprising, because India itself is, it's a highly corrosion-prone country, and And if you look at the coastline of the country, it's almost 7,500 kilometers. And as you can see from this corrosion hut, almost 90 to 95%, falls under the corrosive region. And in the coastal region, the corrosion is extremely severe. It starts decreasing, but if you compare that with any other country in the world, the corrosion levels in India are extremely significant. Now, these are some of the actual photographs which I'm showing. So this is the bus body workshop of Karnataka State Road Transport Corporation at Kengeri in Bangalore. Now, Bangalore is a landlocked, it's a landlocked city. It's far off from the coastal region, but even after 3 to 4 years, this is the condition of the structure. The reason being that, the quality of the groundwater. And it's not only Bangalore, let me tell you, Jaipur, they face massive amount of corrosion, primarily because of the groundwater quality. It has got, almost 6,000 ppm of chloride level. Second is, the weight reduction. Like Nagma had very, beautifully explained that, what could be the weight savings with stainless steel. So yes, weight reduction plays a very important role because from the diesel point of view, this is a global study which was done by the Institute of Energy at Heidelberg, and it was commissioned by the International Aluminium Institute. So what they found out was almost 1.3 liters of diesel is saved for every 1,000 kg of weight reduction for every 100 kilometers of travel. And if you look at the energy savings, when we talk about electric vehicles, that again comes to about 6 kilowatt hour, 5 to 6 kilowatt hours saved for every 1,000 kg weight reduction for every 100 kilometers of travel. And that's the reason why, lightweighting has become the most essential parameter when we look at, material selection, both for diesel vehicles as well as for electric vehicles. So why stainless steel? Now, this is the fundamental difference between a stainless steel or galvanized or a painted steel. Because if you look at galvanized, if you look at a painted steel, they all perform the same function. That is, they are all there to reduce corrosion. So what is so unique about stainless steel? So this is the self-passivating characteristic. So in self-passivation, what happens is the chromium from the metal itself, it reacts with the surrounding oxygen to form a layer of chromium oxide. And this deposition of chromium oxide on the layer, that imparts the corrosion resistance to stainless steel. So even if the film is broken, then immediately the chromium from the metal, it reacts with the surrounding oxygen to reform this chromium oxide layer. And that is the reason why, the durability, the longevity with stainless steel is significantly higher as compared to galvanized or a painted material. Now, in galvanized or painted material, what happens is, you either have a zinc coating or, the paint. Now, both are physical coatings. And therefore, normally what happens is during any kind of bending operations, forming operations, welding, from micro regions, this galvanic, zinc, the zinc film or the painted film, that peels off. And this phenomenon is known as flaking. So from the areas where flaking happens, then immediately the surrounding, the chlorides in the atmosphere, it starts attacking the carbon steel substrate and corrosion starts. Now, once the corrosion starts, it's almost impossible to stop that. So this is where the difference of stainless steel lies, as compared to a galvanized or a painted material. So, so what makes stainless steel self-passivating? Well, it's because of the chromium content, and this graph primarily shows that the chromium content has to be above 10.5%. That's the minimum level, and therefore, when we define stainless steel, we define it as any kind of alloys, an iron-based alloy, where the chromium content is minimum 10.5% and above. Because, if you can see, at this level, at this 10.5%, there is a significant jump in the corrosion resistance of the material. So, even amongst, various materials, the corrosion resistance varies. Why I am showing this particular figure is because there is a conception that aluminium provides a higher corrosion resistance as compared to stainless steel. But if you look at the electrogalvanic series, and what happens is, if you look at the materials which fall on the left-hand side, so they are more noble. That means, they are more corrosion resistant as compared to materials lying on the right. So if you compare aluminium, with stainless steel, stainless steel is towards the left. That means the corrosion resistance of stainless steel is higher as compared to aluminium. And therefore, today you must be all seeing all the metro cars which are running across the country. They are made out of austenitic stainless steel and they are all unpainted. Whereas, globally, if you look at any vehicle in aluminium, they have to be painted. So the corrosion resistance of stainless steel is significantly higher as compared to aluminium. Yeah, I'll just skip. And therefore, this is one of the primary reasons why, today Indian Railways have adopted stainless steel on an extensive basis. So if you look at any kind of passenger coaches, be it the Durontos, the Shatabdis, or the Bombay, the trains, they are all made out of stainless steel. Even the wagons, the major wagons carrying iron ore, coal, they are all made out of stainless steel. All components, which are being used by Indian Railways, I would say 95% of them are with stainless steel. So what are the various possibilities in stainless steel from the transportation segment point of view? So here, I would like to just juxtapose what is the trend in India vis-a-vis what's happening in the world. So if you look at the Western countries, the usage of stainless steel in the ART segment, when we say ART, it means automotive, railways, and transport. So that's about 15%. Whereas if you look at what's happening in India, it's about 3 to 4%. So, there is a huge potential of stainless steel being utilized in this particular segment. And over the next few slides, I would like to just take you across what are the various possibilities, which exist in stainless steel. Yeah. So, we have buses, and I'm going to share how it has picked up in India. We have trucks, we have load bodies, we have tippers, and of course we have tankers. But I'll focus on the buses segment in particular. And of course, if you look at the components, what Mr. Kathuria has also mentioned, fuel tanks. Fuel tanks is a classic case, where stainless steel could be used, and it has been used by some of the auto manufacturers in the country. We have the heat shields. This has been particularly developed for Tata Motors, and they are using it on an extensive basis for all their commercial vehicles, primarily the trucks. We have the bumpers and, of course, the exhaust system. So in terms of buses, when we look at stainless steel, it's not a new phenomenon. Globally, almost all the major manufacturers are using buses in stainless steel. Greyhound is, one of the well-known manufacturers in US. Silver Eagle is a well-known manufacturer in UK. And as you can see, they are using premium quality stainless steel because they are keeping the bus bodies unpainted. If you look at Optare, which has now been taken over by Ashok Leyland, it's a UK-based company. Scania, they are all using in painted form because they are using ferritic stainless steel, a stainless steel which has lower chromium content, and therefore the corrosion resistance is not as high as 304, but painted surfaces are fine enough. Volvo, globally, they are using stainless steel. Again, sometimes they are using ferritic. In some cases, they are also using a 304 grade of stainless steel. Solaris, which is one of the leading electric bus manufacturers, they use stainless steel. And, these are some of the photographs which I have taken. So in Europe, I would say 90 to 95% of the buses make use of stainless steel, primarily to reduce the weight. Because, these electric vehicles, as you reduce the weight, either the life of the vehicle, of the batteries increase, and these batteries, they're extremely costly. I think in India it costs about 70 to 80 lakhs. Now in India, what we have proposed and what many of the bus manufacturers have now started using is a grade called 200 series of grade called JT. And so what is the uniqueness of this grade? One is in terms of the yield strength. As you can see, the yield strength of this particular grade is 700 in the tube form. It's 700 megapascal minimum. Whereas if you look at the GI tubes which are being used today, they are either YST 240, that means the YS is 240 megapascal minimum, or YST 280, that is 280 megapascal minimum. So it's almost 3 times, the strength levels of this particular grade is 3 times that of the GI tubes. Secondly, being highly corrosion resistant, they have a chromium content of about 14.5%. You can, reduce the corrosion allowance. So combining these two, the higher strength and reducing the corrosion allowance by as much as, 15 to 20%, there is a possibility of reducing the weight of the buses by as much as 30 to 35%. In fact, ARAI Pune, they had done a rollover analysis study with this particular grade of stainless steel, and they found that they could reduce the weight of the structure by as much as 750 kg as compared to GI tubes. So and these tubes, as you can see the photographs on the left, in fact, this is what ARAI had asked us to do. They asked us to conduct some bending trials. So we bent all these tubes, and none of them cracked. There was absolutely no issue in terms of bending. If you look at the chromium content, they have got a high chromium and high molybdenum. So both these impart very good corrosion resistance to the material. They have got, a nickel content is about, 0.8, 0.9. So the formability is excellent, and therefore that's the reason why, even if you bend it at almost 80 to 90 degrees, there is absolutely no, no issue of cracking of the material. And the carbon content is substantially lower. It's about 0.1%, and therefore with lower carbon, the weldability improves. In fact, the toughness also improves. So these are some of the, we did some tests, and as you can see, the YS is coming to about, 736 megapascal for various tubular profiles. So this is 25, 25, 1.5. So you can see in all the cases, the YS is, the more than 700 megapascal. Fire resistance properties, if you look at this particular grade, it's a 200 series, it can withstand temperatures, at around 800 degrees centigrade, 800 to 900 degrees centigrade. Whereas if you look at carbon steel, they start degrading at around 400 degrees centigrade. And if you look at aluminium, the aluminium alloys, it starts degrading from about 100 degrees centigrade. So in terms of fire resistance, it can withstand very high temperatures. So that gives the, the passengers the extra time to move out of the vehicles. This is the impact resistance, which I think Nagma had also covered. So as you can see, the fracture toughness of stainless steel is almost 2 times as compared to carbon steel. So some, examples. So we did, a lot of case studies, and what came out, from across all those case studies was that if you are able to reduce the superstructure weight by almost 600 to 700 kg, then the improvement in the fuel, the fuel savings, at the current rate, it comes to about rupees 8,000 to 10,000 rupees per month. The initial increase in the cost, because stainless steel is a costlier material as compared to GI tubes, it comes to roughly about 50,000 rupees. And therefore, within a period of 5 to 6 months max, you can recover the cost. And then, over the life cycle of 12 years, that's the caudal life which is considered in India, the savings is almost 10 to 12 lakhs per stainless steel bus. And these are all actual examples of stainless steel being utilized in various buses in the country. So this is, a case study of Andhra Pradesh State Road Transport Corporations. In fact, they had been, they had developed 2 stainless steel buses in 2017 and 2018. So they had been monitoring the performance for all these 5 to 6 years. And this is what they have found, that there is an improvement. The weight reduction which they got was about 370 kg per bus. There was an improvement in the mileage from about 5.53 to 5.67, and the diesel savings was coming to about 6,500 rupees. And so over the total life of 11 to 12 years, they expect a savings of almost 8 lakhs per bus. And that is the reason why this financial year, their VCMD, he has approved development of 150 numbers of stainless steel buses for APSRTC. So these are some of the customers who have already started utilizing stainless steel tubes for their buses. JBM for their electric vehicles, they are using this particular grade of stainless steel, JT. Veeravana for their tarmac buses, those are also electric buses. They have started utilizing this particular grade of stainless steel. APSRTC, as I have told you, 150 numbers of buses are being developed, are being fabricated in this financial year. PMI coaches, another very well-known player in the electric bus segment, they are going ahead with stainless steel tubes and sheets. Similarly with Electra, as well as some of the private bus body fabricators in northern India. Yeah, so this was on the buses. On the tippers, I would just like to show that there are in tippers as well. We can look at this particular grade of stainless steel, because in many of these tippers, in fact about 70 to 75% of the tippers, the body is made out of carbon steel, that is IS 2062 grade A, where we can have this stainless steel, pitched in. So these are some of the examples. Of course, globally they are using stainless steel, but the photographs below show the two of the tipper bodies being fabricated out of stainless steel, this particular grade JT. Load bodies, if you see globally again, people are using stainless steel, but they're using very premium quality stainless steel 316 or 304. In India, of course, we can look at JT, and these are some of the photographs of Indian load bodies being fabricated out of stainless steel. Yeah, this is another area where we are seeing a lot of demand coming in. Hopper tippers are basically which are used for carrying the the municipal waste. So there, already few prototypes have been developed by Tata Motors in stainless steel, and we are seeing some demand coming in from various municipal corporations. Tankers, I'm sure many of you would have seen these tankers in stainless steel, particularly the water tankers. If you look at the edible oil tankers, that are also being now converted into 200 series of stainless steel. And finally, we have these salt carrying trolleys. So here also from the Gujarat region, we are seeing stainless steel being preferred for this particular segment. Car body, this is, I think, would be a futuristic concept, but just to tell you historically, there have been cases where the entire car body has been made out of stainless steel. Of course, Tesla, if you look at the photograph on the right, down below, so the Cybertruck of Tesla is again a completely stainless steel body. But if you look at some of the components like the A pillar or the B pillar, there some of the car manufacturers in Europe, they are trying out stainless steel. Yeah, fuel tanks, I think Mr. Kathoria has already spoken about that. Ashok Leyland, for some of their vehicles, the trucks, they are using this stainless steel fuel tanks. The grade is again 200 series, 201 grade. Similarly, Tata Motors, for their World Truck, they are using this SS439. It's a ferritic stainless steel. And of course, globally, if you see Ford, they significantly, extensively use this stainless steel for their fuel tank manufacturing. Heat shields, as I've told you, it's a new development. For the last 2 years now, Tata Motors is extensively using stainless steel, heat tanks. And this is made out of a grade called 204 copper. Yeah. Bumpers, this is, although Europe people are using, but in India, we are still to see that development. But Ashok Leyland did some trials but I think now plastics has come into the picture. Yeah. So finally, looking at the sustainability point of view, so why stainless steel? Because if you see, stainless steel is 100% recyclable. So whatever stainless steel we manufacture is from scrap, and therefore it's a completely green steel. So that is again, from the environmental point of view, from the sustainability perspective, stainless steel seems to be the most suitable material. Thank you.